All right, so this is going on page 24. Yes. All right, so if you took pre-cal in the summer, I'm not sure if y'all actually learned these rules or not. I will tell you, pre-cal during the school year, I skip over these rules, and we just kind of go to some limits, just so we can understand basic limits, because us figuring all this would just like have really freaked some of y'all out last year, and it may be freaking you out right now, but it shouldn't. It's not nearly as bad as it looks, all right? But it says if L, M, C, and K are real numbers, right? So we're just working in the real number system. And then we know that the limit of f of x as x approaches c is some value L, and the limit of g of x as x approaches c is some value m. What this is saying right here is that the limits exist. Okay, they have to exist for these just to straight up work like it says. Okay. So your basic rules, most of them are self-explanatory. I feel like I want to give you some examples for number 1 though. So your basic rules, the limit of b as x approaches c equals b. So we're going to do a couple of little examples right here. So we could have, what that's saying is the limit of 5 as x approaches 2. Like if you have something like that, it's just the limit of a number as x approaches whatever, the answer is just 5. Because there isn't anything else going on there. It's like one of the ones that's so easy that might seem wrong, but, and then this one, if I have the limit as x approaches 2 of x, so this is one where you really just substitute it in. You substitute in the 2 and your answer is 2. So b has to be a real number also. So that's like super basic, but those things are true. If you're going to take the limit of 2 functions being added together, you can take their limits independently and then add them together. Because remember, L and M is just, L is the limit of f of x, M is the limit of g of x. So the sum rule, you can just find them separately and add them together. That's all it's saying. It's that simple. Okay? The difference rule, same thing. You can find each limit and then just subtract them. The product rule, you find each one and you can multiply them. The quotient, you find each one, you can divide them, but m can't be 0. Right? And so hopefully most of these kind of make sense. And then, you know, it's not like a whole bunch of rules you have to memorize. They just look a little crazy. If you have a constant multiple, constant k, so this is 5 times f of x or whatever, you can actually factor that out. So it's really just you find this limit and you multiply by whatever that number is. And then your power rule. R and S are integers. S is not 0. So then the limit of f of x taken to this power, you just kind of ignore the power, find the limit, and put the power on it. Okay? That's all that's happening there. It's that simple. All right? We're all good with that? And those are your basic rules. Basically, it's telling you addition, subtraction, multiplication, and division work this, you know, like with limits like you would think anything else does. Okay. So you are given limits here. We're not having to find them. We're given the limit as x approaches c of f of x equals 3/2. The limit of g of x as x approaches c is 1/2, and we want to evaluate the following. Okay, so this is the same thing as, this is your scalar multiple, so I'm just going to have 5 times something. Right? Does the limit of g of x exist? Yes, it's right here. They gave it to me, right? What is the limit of g of x as x approaches c? 1/2. So I get 5 times 1/2, and that gives me 5/2. Not 2.5, not 2.5, 5/2. Okay? We good? All right, so the limit as x approaches c of f of x times g of x. Does the limit of f of x exist? Yes. Does the limit of g of x exist? Yes. So I know what they are. I get 3/2 times 1/2, and that is 3/4. Okay. Does the limit of f of x exist? Yes. G of x? Yes. So then I can just use the limit of f of x, which is 3/2, plus the limit of g of x, which is 1/2. What's that going to give you? 2. All right, everybody with me so far? All right, does the limit of f of x exist? Yes. Does the limit of g of x exist? Yes. Is the limit of g of x 0? No. So then I can just divide them, and this is going to give me 3/2 divided by 1/2. What does that give you? 3. Any questions at this point? Okay, so there was new rules, but they were pretty basic. Okay, so I have the limit of the cube root of f of x as x approaches c. All right, well, can I rewrite that cube root as a what? 1/3. So this is the same thing as the limit as x approaches c of f of x to the 1/3 power. So what's the limit of f of x as x approaches c? 27. So I can have 27 to the 1/3 power. What's 27 to the 1/3 power? 3. Okay, we good? All right, so I want y'all to try it. I want y'all to do C, B, and D. Mm-hmm. Wait, what? Mm-hmm. So you can take the cube root and square it. Or you can square it and take the cube root, but that'd be yucky. Okay, let's look at these. Let's look at B, right? So the limit, this is like being multiplied by 1 over 18. So all I have to do is substitute in this limit. The limit of f of x is 27, so I get 27 over 18. What does that reduce to? 3 over 2. Okay? It's okay. If you messed up on the fraction part, so here's the good news. Remember I told you there's such thing as a safe stop in calculus. You don't have to finish everything all the way. We could have stopped here. We could have stopped here. And if that's your final answer, it's perfectly fine. However, if you're doing this in the middle of something, it may be to your benefit to reduce it. Or if it's a multiple choice question, this might be the answer and not this, right? So you still need the skills to finish it up. But if that is the end question and you're just answering it, we could just stop. Okay? So I'm going to show you when safe stops and, so let's go ahead and look at the rest of these. This is 27 squared. What's 27 squared? 729. Cameron didn't want to have to think, so he asked me, can I just stop here? And that's when I said yes, we could have stopped there. Because what you don't want to do is you don't want to get this correct and then you make a fraction error, and then if this is your final answer and it was wrong, you will get it wrong even though you knew what you were doing. Okay? So we're going to be able to stop. So that, go ahead. Mm-hmm. Yeah. So, no, that's okay. That's why I didn't tell you beforehand, because I wanted you to kind of see that, because really, what are we trying to understand? We're trying to understand the limit rule, and there's a reason that every course up until now you've had to finish it, because really at some point you don't really understand when you can stop and when you can't. Because like I said, you still need those skills, but you don't always have to use them. So on D, we could leave this as 27 to the 2/3 power. Okay, that's an acceptable answer to this. And then there's two different ways to do this. I could square it, 729, and then take the cube root, but yuck. Instead, I think I'd rather take the cube root and get 3 and then square that and get 9. Okay, but this would be your, what's called a safe stop. Okay. Any questions at this point? We good? Just applying some rules here. Okay, so now we're going to apply them graphically. All right. You have the graph of f of x. You have the graph of g of x. Okay. So I'm going to take the limit. We can take the limits separately here, right? So the limit of f of x as x approaches 4. Does that exist? Yes, and it is 2, right? Plus the limit of g of x as x approaches 4. Does that exist? Yes. What is it? 1. So your answer is 3. Okay. Easy enough? All right. Now look at B. The limit of f of x as x approaches 2. Does it exist? As x approaches 2, the limit does not exist, does it? Does it exist for g of x? Yes. We'll just pretend like it's 1/2 even though it's not. Now, remember, those rules that we have only work if the limits of both exist. The limits of both don't exist. If they don't both exist, then we have to look at the limit from the left and the limit from the right. Because remember, the only way a limit, the reason this limit doesn't exist is because the limit from the left and the limit from the right aren't the same, right? But it's possible that even though one of these does not exist, that this limit still could work. So now we have to look at the limit, the limit as x approaches 2 from the left of f of x plus g of x. Okay, so if I go 2 from the left, my limit is -1 for f of x. And we'll just say 1/2, because all we really care about is whether or not it exists right now. We'll go with 1/2. Okay, so that's -1/2. Then we have to do the limit as x approaches 2 from the right of f of x plus g of x. And 2 from the right, I'm approaching 1. 2 from the right, I'm approaching 1/2, and that's 3/2. Are these the same? Since these are not the same, my answer overall is does not exist. This is why it does not exist, not just because one of them didn't, okay? Let's jump to letter F. Okay, we're going to come back and do the rest, but let's jump to F. The limit, so I have x minus 5 times g of x. So to do this part, all I have to do is substitute in the 5, right? That exists. Does the limit as x approaches 5 of g of x exist? No. So we're going to have to do the same thing again. We're going to have to say the limit as x approaches 5 from the left of x minus 5 times g of x is going to equal, well, what's the limit of x minus 5? 0 times the limit is g of x approaches 5 from the left. That limit is 4, and that's 0, right? And then I have to do the limit as x approaches 5 from the right of x minus 5 times g of x. So that's going to be 0 again times, as we approach g of x, as we approach 5 from the right, what's my limit? 1. Are these two limits the same? Yes, they are. So your answer here is 0. So just because one piece does not exist doesn't mean that the whole thing is. Okay, does that make sense? Then you got to check it from the left and the right. All right. So let's go back to C. The limit as x approaches 3 of 4 times g of x. All right, so g of x, as x approaches 3, what's the limit? 0. So this is 4 times 0, which is 0. So then we look at D. Does the limit of g of x as x approaches 6 exist? Yes. Does it exist for f? Yes. Okay. And f is not 0, so we can actually do this then. What is the limit of g of x as x approaches 6? 3 over -1. That gives us -3. You do E. Did you get 2? Yes. All right. What questions do you have? Okay. We good? Awesome. All right. Let's look at what it might look like on the AP exam. So the table above gives limits of f and g. What is the limit as x approaches 3 of f of negative x over 2 times g of x? So what's with the negative sign? What do you think that means? If I want to know as x approaches 3, that means I really want to know here as x approaches what? -3. Do you have the limit as x approaches -3? Yes, they gave it to me. So there's nothing I can do here with this one to figure that out. Like, they'd have to give it to me. So I'm actually not using that one. this exists, I'm using this one, and g of x exists and it's not 0. So that means I'm going to end up with 8 over 2 times what? 2. So what's your answer? 2. So are we all okay on the whole f of negative x thing? Yes? Okay, good deal. All right, so I want to look at a couple of other questions that you don't necessarily have on there. We're going to work through a few more, because apparently I went a lot quicker than planned. I don't know what page this is. Okay. Can y'all read this okay? So the limit of f of x as x approaches c is 27. G of x is 3/2. I want to evaluate the limit of 5 times g of x. Hey, we're up here. So what would I do? 5 times 3 over 2. And what's that going to give me? 15 over 2. Exactly. Okay? We're just going to click through some of these together. All right. F of x over g of x. So this is going to be 27 over 3/2. Multiply by 2 over 3. So what's that going to be? 18. Okay, we understand how we got that? Okay, we're not even paying attention, so this is the same question we just did. Okay, so let's look at one of these. We're going to talk about this a little bit more tomorrow, but I want to talk through some of them. This is the same pictures you had in front of you, but this is the limit as x approaches 7 of g of f of x. All right, so that means I go and I find the limit of f of x as x approaches 7. What is that? 0. So then I find the limit. So basically now this changes from 7 to 0 as g approaches 0, and my answer would be 1. Okay, it's like a composition. Okay, so do I need to talk you through that again? No? Because some of these are going to get a little weird, so we're going to make sure we really understand the super basic one. Like I said, I'll talk you through, I'll have some more examples tomorrow, but I want to at least look at them. So f of x, the limit, not the value, right? We're still talking limits. So I find the limit of f of x as x approaches 7, which the value and the limit happen to be the same. It's 0. So now this becomes, instead of 7, now it's 0 for g, and as g approaches 0, your limit is 1. Okay? See how that works? It's a composition thing going on there. Okay. Let's see. I think there's a couple more. I think this one, let's see. I think this is the same one we already did. Did we do these? Yeah, we did that one. That one does not exist. Some of these were the same. Okay. So let's look at this one. The limit as x approaches 1 of f of x times g of x plus 1. So the limit as x approaches 1 of f of x is 0. But the limit as x approaches 1 of g of x plus 1 does not exist, right? You see that? Because when I add 1, I'm actually at 2 right here, right? So that's when we have to do the limit from the left and the limit from the right. Well, this would be from the left. Let's see, we'll just do 1 from the left and 1 from the right. This would be 0. Both of them are 0 each time. If I go from the left, that's the left, yeah. The left is 1, and the left is negative 1, 0, and 0. So it's 0, okay? Did I really need to find these? Think about that. Not really, because it's 0 times something, right? Now, I say we didn't need to, but if you're explaining like this is multiple choice, but if you were explaining yourself, you would have to show those two things that you actually found them. So you would kind of have to prove yourself there. So what about this one? F of x times g of x. Well, does the f of x one exist as x approaches 1? Yes, it's 0. Does the g of x exist as x approaches 1? Yes, it's 1. But the answer is still 0 because it's 0 times 1. What? Oh, I thought you said, how do you know that? Making sure. see. Okay, so that's it pretty much right now. All right, let's go ahead. Since